Welcome to the course on error control coding and introduction to convolutional codes. Today we are going to discuss some of the applications of convolutional codes in practice. So before that, we will just do a very brief historical timeline of how coding theory has progressed over years, and then we will talk about some applications of convolutional code. We will first discuss some applications for deep space exploration, and some applications for modems, and finally some applications of convolutional code in wireless communication standards. So as we know, 1948 Shannon founded information theory, and then subsequently around 1955 Elias came with convolutional codes. Around 1960s Reed-Solomon code and LDPC codes were discovered, and around 61-63 Wozencraft and Fano came up with sequential decoding of convolutional code, which allowed us to decode convolutional code with very large memory order. Around 1967-68 Viterbi's algorithm for maximum likelihood decoding of convolutional code came, and then around 74 BCGR algorithm was proposed. In late 60s and early 70s, convolutional codes and concatenated codes found applications for deep space applications, and around 1977 coding and modulation was combined together to design trellis coded modulation, and they subsequently found lot of applications in designing coding for modems. And then finally around 1993 turbo codes were discovered and LDPC codes were rediscovered, and then from late 90s onwards, early 2000, and people started proposing these codes for various standards, and they found applications in many communication standards. So that's a brief outline of how things have evolved over 50-60 years. So let's start with applications of convolutional code. Now Pioneer Mission was 1968, and they use a rate half convolutional code which has constraint length of 20. So there were 2 or 20 states, and they use sequential decoding to decode this code. The receiver used a 3-bit quantized soft decision, and it was implemented on a 16-bit mini computer. It provided a coding gain of roughly 3.3. So it got for a probability of around this, it gave a coding gain of about 3.3 dB. Next, around 70s, NASA started using this concatenated code. Outer code was a Reed-Solomon code, and inner code was a 64 state convolutional code, rate half convolutional code, and it found a lot of applications. The overall code rate of this was 0.43, and gap to capacity was only 2.5 dB. It provided a coding gain of around 7.3 dB at bit error rate of 10 to minus 5. Another big development was when in Galileo's mission this antenna failed to deploy, primary antenna, when it failed to deploy. So there was an elaborate concatenated coded scheme which used a 2^14 state convolutional code as the inner code, and Reed-Solomon code as outer code, and a big Viterbi decoding algorithm was proposed, which could work over such a large number of states, and that was also a very impressive step forward in terms of coding application is concerned, because it was able to salvage this mission because of this very nice concatenated code used, and it was successfully deployed. It provided a coding gain of around 10.2 dB and it was able to achieve bit rate close to 10 to minus 7. And finally, as I said, from early 2000 now, this is the era of turbo codes and LDPC codes, and they are finding applications from deep space to mobile communication standards, TV broadcasting and things like that. Now, another area where error control coding and this convolutional code made a major impact was in coding for modems. So, around mid 70s, Ungerbock came with how to combine coding and modulation, and he came up with this trellis coded modulation, and these codes were heavily used in designing coding schemes for data transmission, basically over public switch telephone network. So, some of the applications I have listed here. So, initially we had 9.6 kbps transmission that uses an 8 state code. Then finally, for a 33 kbps transmission, they use a 16 state 4 dimensional trellis coded modulation scheme, and there was an optional 32 state 4 dimensional trellis code which was also specified in this standard. But when we progress to digital backbones, then basically there was no need for these codes, and so the V90 or V92 standards, they essentially do not use any of these coding techniques. But in mid 80s and early 90s, there was a lot of they were very successfully, these codes were applied for coding for modems. Now, currently these techniques are also used for high speed wireline modems like ADCL and other applications, and of course turbo codes and their variants are also finding applications here. So, I like to conclude basically with giving some examples of communication systems. So, our GSM uses a convolutional code of memory 4 and rate 1/2 code, and in this table I have listed some of the applications of turbo codes in recent standards. I mean, so starting from digital video broadcasting standard to 3rd generation wireless standard to deep space exploration to satellite communication applications, and you can see there are this binary turbo code that we talked about. This do binary turbo code essentially uses like rate k by n code, where k is greater than 1, and there are additional bits, tail bits that have been added in some of the cases for termination of this encoder, and in some cases where you see this circular thing, they have used a circular recursive encoder. So, these are what they call, what is known as tail biting encoders. So, the starting and ending state are same. So, the trellis is like a circular trellis, so they do not need any termination bits, and these are the code generator polynomials in octal notation and some of the rates that have been used for these codes. Thank you.